Hi students, in this class we shall be discussing mean deviation from measures of dispersion for statistics. Okay. Now, there are two types. Okay, we already know there are two types of measures of dispersion. One is the absolute measure and the other one is the relative measure. Okay. So, the relative measure is known as coefficient of mean deviation. The absolute measure is known as mean deviation. Okay. So, we will be studying mean deviation and coefficient of mean deviation. Okay. Okay. The mean deviation is generally calculated about a particular measure of central tendency. It could be either the mean or the median. Okay. So, what is mean deviation? Mean deviation for a given set of observation is defined as the arithmetic mean of the absolute deviations. The arithmetic mean of the absolute deviations of the observations from an appropriate measure of central tendency. Suppose if we fix A as the mean, then the mean deviation will be called mean deviation about the mean. Okay, if the central tendency will be taken as the mean, then we get mean deviation about the mean. Otherwise, if we take it as the median, we get mean deviation about the median. Okay. So therefore, mean deviation, it is defined like this. Okay. So this is mean deviation about some measure of central tendency. Say any appropriate average A will be defined as, it is defined as the absolute deviations of xi minus A by n. Okay, sum of absolute deviations divided by n. Okay, that is, what is this? This is sum of absolute deviations divided by total number of observations is known as arithmetic mean of absolute deviations of the observations taken from the appropriate measure of central tendency. Okay, here in this case is A, which A could be either x bar or A could be either x bar or A could be either the median. Okay, it could be either x bar or it could be either the median. In case if it is x bar, we say it is mean deviation about the mean. Otherwise, if it is median, we say it is mean deviation about the median. Okay. So, let us first of all take an example for mean deviation about the mean. Okay. So, suppose if we are having xi or the observations as say 1, 2, 3, 4 and say 5. Okay. Then how to find mean deviation about the mean for these observations? We clearly know that the mean in this case is 3. Okay. The mean in this case is 3. So therefore we take 3 as A. Okay. So we have modulus of xi minus A. A could be any value. Here we are taking 3 as the average. Okay. So therefore 1 minus 3 is minus 2 positive minus 2. That is positive of minus 2 will become plus 2. Here it is plus 1. Here it is 0. Here it is 1 and here we have 2. Okay. Now for this formula we need to have the sum of all absolute deviations. So that is 3 plus 3 is equal to 6. Okay. So then total number of observations is 1, 2, 3, 4 and 5. So therefore mean deviation about A is defined as, the mean deviation about A will be defined as the sum of absolute deviations. Okay, sum of xi minus A, the sum of absolute deviations divided by n. Okay, we shall put the values, that is, this is 6 divided by 5. So we have 1.2. So 1.2 is the mean deviation about A. Okay, if A is the mean, we will call it as mean deviation about x bar, or if mean, instead of mean we take median, we call it mean deviation about the median. Okay, mean deviation about x bar or mean deviation about the mean. This is what we are going to study. This is for individual data. So, the formula for absolute measure of mean deviation is like this. So, mean deviation about A is equal to 1 by n into sigma of xi minus A, okay, for individual observations. Now, in case if we have frequency associated with the individual observations, we have a frequency distribution, okay. So, that is called a discrete series. So, when we have a discrete series, what we find is that we need to, that particular observation repeats fi number of times, xi repeats fi number of times. So, therefore, the corresponding deviations xi minus a will also repeat fi number of times. So, therefore, the formula becomes like this, okay. Instead of small n, it becomes capital N, where capital N is the sum of all frequencies. Capital N is the sum of all frequencies, and this fi will be present here in multiplication form, okay, where fi is the frequency of the ith class interval, n is the sum of all frequencies. Now, in case if we are having a continuous frequency distribution, that is class intervals are given, then also the same formula will be used, but we do not have xi's. So, xi's will be taken as the mid value of those classes or the class midpoints of those classes will be taken or considered as xi, okay, that is it. That is the small change that we observe in this case, okay. Now, let us discuss relative measures of mean deviation, okay. The relative measure of mean deviation is known as coefficient of mean deviation, okay, coefficient of mean deviation, and it is defined as mean deviation about A divided by A into 100. So, if we have a coefficient of mean deviation about x bar, then we need to find out MD about x bar divided by x bar into 100. That is mean deviation, coefficient of mean deviation about the mean, okay. In case if we are finding coefficient of mean deviation about the median, then we, instead of x bar, we will use the median. That is the only thing, okay. Now, let us discuss some properties of mean deviation, okay. Let us discuss some properties of mean deviation. So, the first property says that mean deviation does not possess any mathematical properties. The property itself says that the mean deviation does not have, or it does not possess any mathematical properties. Second property says that if all the observations assumed by the variable are constants, then the mean deviation is 0. If all the observations assumed by the variable are constant, then the mean deviation is also 0. That is again very clear. If we have different values, say if all the observations are 3, 3, 3 and 3, then the mean will come out to be 3 itself. The mean will be 3 itself. So, each position we have absolute deviations as 0. So, the sum will be 0. So, therefore, when the formula will be applied, then we get 0 as the mean deviation, okay. So, that is what we mean, that in case if all the observations are equal to some constant value, say k, then the mean deviation will be 0, okay. Now, third property, the third property says that mean deviation will be minimum. The mean deviation will take its minimum value when the deviations are taken from the median. This is very important. This property is very important. This property is again very important, okay, for examination point of view. The MCQs will be asked based on this property. Mean deviation takes its minimum value when the deviations are taken from the median. Say suppose if we take the sum of absolute deviations, okay, that is sigma modulus of xi minus me, okay, the sum of absolute deviations will always be less than or equal to the sum of xi minus any other value, okay. Instead of a, if you take the median, that value, the sum of absolute deviations will be minimum, okay. It will be less than or equal to any other absolute deviation, okay. So, that is what we need to understand. So, in case if we divide by 1 by n, divide by 1 by n on both sides, it says that mean deviation will be minimum. Now, the fourth property says that the mean deviation remains unchanged due to the change of origin. Means the mean deviation is not affected by change of origin, but it changes in the same ratio due to the change in scale. Again, similar to that of range. If you multiply by some number, if you multiply each observation by some number, then the mean deviation also will get multiplied by the absolute value of that particular number. Okay, the mean deviation will also get multiplied by the absolute value of that number. So that's it. Let us understand this. Y is equal to ax, a means a plus bx, where a and b are constant, where a and b, here it is not printed, a and b are constants. Then we can have the mean deviation of y is equal to modulus of b into md of x, where b is the scale factor. Okay, it is the scale factor. Mean deviation depends or is affected by change in scale, but it is not affected by change in origin. So if you add something to each observation, or if you subtract something from each observation, the mean deviation is not going to get affected. Okay. Now we shall discuss concept practice problems. So the first problem is, what is the mean deviation about mean for the following numbers? What is the mean deviation about mean for the following numbers? 5, 8, 10, 10, 12 and 9. So first thing is that we prepare the table and the corresponding deviations about the mean. Okay, we need to find it about the mean. So let us prepare the table here. So when we prepare the table, first we write down all the exercise, that is 5, 8, 10, 10, 12, 9. Okay, and then we find the mean of the observations. So to find the mean of the observations, we need to add the observations. So when we add the observations, we get 54. So therefore, mean will be equal to x bar, which is equal to sum of all observations divided by number of observations. The sum of all observations is given by 54, and what is this? This is 6. How many observations are there? 1, 2, 3, 4, 5 and 6. So there are 6 observations. 54 by 6 will be equal to 9. So we have 9 as the mean. Now we need to subtract each observation from 9 and then take its absolute value. Okay, if it is negative, make it positive and write down here. Same way, it is 5 minus, this is 5 minus 9 modulus. What do you get? Here it is minus 4 modulus of minus 4, which is equal to 4. So same way we can calculate for each value. So what we get is this. Okay, what we get is this, because why are we taking xi minus x bar? Because the formula requires us to do so. Sum of absolute deviations from the mean is required. Instead of a, we are taking x bar. Okay, sum of absolute deviations from the mean. So what we get here is 9 minus 5 is 4, 9 minus 8, I am subtracting the smaller number from the greater number. Okay, so that I always get the positive value. So final value here, the sum is 10. Okay, the sum is 10. So what I get here is, this is 10 by 6. Okay, so that's it. So what we get is 10 by 6 is equal to 1.67. Okay, mean deviation is 1.67. So what are we doing? First of all, we will find the mean, that is add all the observations, find the sum and then divide by total number of observations. That is, we get the mean as 9. Then we find the deviations, the positive deviations from the mean of each observation, and that is what we write down here in this table. Then we add all those values, 4 plus 1 plus 1 plus 1 plus 3 plus 0. What we get here is 10. This is the sum of all absolute deviations. Now the sum of all absolute deviations divided by the total number of observations will give you the mean of, or the arithmetic mean of the sum of absolute deviations taken from the mean. Okay, so what we get here is the mean deviation about x bar. Okay, that is 1.67 in this case. Now let us look at the second problem. Okay, read the question. The second problem says that, what we have in the second problem? Second problem says that find the mean deviation about the median. Okay, here we need to find the median for the following profits. So we need to arrange them in ascending order. So when we arrange them in ascending order, what we get here is this. Okay, that is 52, 56, 68, 70, 75, 80 and 82. So here we can observe that 70 appears to be the median. 70 appears to be the median. Okay, so we have 70 as the median. Now what we need to do, we need to find the mean deviation. We need to find the mean deviation. So that is, we prepare the table for mean deviation, because we need to find out xi minus the median for each observation. So we are preparing the table, and the table will be like this. Okay, so it is 52 minus 70 will be 18, and same way 52 minus 70 absolute value, it is 18, 56 minus 70 and then positive is equal to 14, and 68 minus 70 is equal to minus 2, which gives you positive 2 here. 70 minus 70 is 0, 75 minus 70 is 5, and 80 minus 70 is 10, 82 minus 70 is 12. When you add all these observations, you get 61. Okay, we get 61, and just need to put these values into this formula. This is sum of all xi minus me. This is xi minus me, and what we have here is, this is sum of all xi minus me. Okay, so sum of absolute deviations taken from the median is 61. So what we get here is 61 divided by number of observations. Number of observations is 7 in this case. So 7, 61 by 7, whatever comes out, it will be equal to, that is the mean deviation, that is 8.7243. Okay, 61 divided by 7 is 8.7243. Okay, so therefore what we observe here is, the question was given that each number was in thousands. Okay, the question was that each number represents profits in thousands. So we get the mean deviation as this whatever value into thousands. Same way the median will be 70,000. Okay, so that's it. Let us go on to the coefficient of mean deviation. Let us try to find out coefficient of mean deviation about the median for this question. Coefficient of mean deviation will be given by like this. Okay, mean deviation about the median about the median divided by median into 100. So what we do, we just put in the values. This is the value divided by the median. Okay, that much thousands. Okay, what we have here is 8724.30 into, divided by 70,000 into 100, which will give you 12.46, and 12.46 is the coefficient of mean deviation about the median. Okay, 12.46 is the coefficient of mean deviation about the median. Now let us move on to the next problem. Consider this problem. Here we have a discrete frequency distribution where observations are given, xi is given like this and fi is given like this. So 1 is repeated 5 times, 3 8 times, 5 9 times, 7 2 times and 9 1 times. So we need to prepare the, first we need to find the mean, because we need to find the mean deviation about the arithmetic mean. So first of all we shall prepare the table. What we have is 25. Okay, so we can have the formula as mean is equal to sum of all fi xi divided by sum of all frequencies. What is the sum of all frequencies? Sum of all frequencies is 25, and the fi xis will be equal to, now that is 97 divided by 25, 97 divided by 25. So when you divide this, what you get, you multiply by 4 in the numerator and denominator, put 2 decimals on the left, what you get will be the solution. Okay, that is 97 divided by 25 becomes 3.38. 97 divided by 25 becomes 3.8. That is the value of the mean. Now we need to subtract 3.38 from each observation and take its absolute value. So the result would be like this, because we need to find the mean deviation about x bar. Okay, so the absolute deviations are like this. So then we need to multiply it with the frequency. These two are multiplied together to get the fi into modulus of xi minus x bar. So then we get this, and the sum is equal to 42.88. The sum of all fi xi we have already found it. Sum of all frequencies is also known to us as n. Okay, we just put these values. This is 42.88 divided by 25. When you calculate, you get it as 1.72. This is your correct value. Okay, then let us move to question number 4. Okay, let us move to question number 4. Look at the question. In this question, we have we need to compute the coefficient of mean deviation about the median for the following distributions. We need to compute the coefficient of mean deviation about the median. We need to compute the coefficient of mean deviation. So for that purpose, first we need to find the median, and then we need to find the coefficient of mean deviation. So to find coefficient of mean deviation, we need to find the mean deviation. Okay, so let us start and prepare the table for median. So this is already continuous. So we know how to find the median. We need to first of all prepare the cumulative frequency distribution for the lower boundary points, less than type cumulative frequency distributions. And in this case, we observe that what is n? What is the total number of observations? Total number of observations is 50. Total number of observations is 50. Okay, this sum is equal to 50. Now n by 2, we calculate n by 2. What is n by 2? It is 50 by 2, that is equal to 25. 25, where does 25 lie? 25 lies, where does 25 lie? Here. So it lies between 20 and 40. Okay, so this is your NL, and this is your NU. This is your L1 and this is your L2. This is the median class. 60 to 70 is the median class. 60 to 70 is the median class. Is that clear? Now we shall move on to find the median. We all know how to find the median. The median, we know the formula as median is equal to L1 plus n by 2 minus NL by NU minus NL into C. Okay, with the class length and everything we know. In case if you don't know how to find the median, then you can check the I button for the corresponding video. Okay, so median is like this. We just put these values and calculate. We get the median as 62.50. Okay, now once we find the median, what we are supposed to do? We need to find the mean deviation about the deviations from the median. So we prepare the table like this. Xi will be taken as the mid values of all the observations. Xi will be taken as the mid values of all the observations, where you know the formula as 1 by n into sum of all fi into modulus of xi minus the median. Okay, so therefore we fill xi's as the mid values. So 40 to 50 mid values, 45, 55, 65, 75. Now we take the deviations from the median, and then the absolute value also we will put here. Okay, so what we get here is 17.50, that is 45 minus 62.50, and we take the absolute value like that. Now you multiply this with fi. These two are multiplied and put here. Okay, so you get fi into xi minus me, and what you get here is this. Okay, so it is 140, 90, 50, 125, and then you add all these values. And what you get is 405. Okay, so this is equal to 405 divided by 405 is the sum of all fi into this, divided by, this is capital N. This should be capital N. What is capital N? Capital N in this case is 50. Capital N was 50. So we have 50. Okay, sum of frequencies is 50. So 405 divided by 50 will be equal to 8.10. Okay, next. Okay, we need to find the coefficient of mean deviation about the median. So to find that, the formula is very simple. Mean deviation about this divided by this value divided by the median, This is the median. Okay, into 100. So the formula says it will be mean deviation about the median divided by median into 100. So it becomes 8.10 divided by 62.50 into 100, and that is equal to 12.96. So that's it for this question. So you can note down the problem. Okay, let us consider the fifth problem. This is based on the change in scale and change in origin type problem. So here the equation that we have here is the relationship as 4x plus 3y plus 11 equal to 0. So what we have here is y will be equal to minus 11 minus 4x. Okay, y will be equal to minus 11 minus 4x divided by 3. Okay, so this is your A and this is your B. This is your B and this is your A. You can put a plus in between in case. So 11 by 3, this is A plus B into x. So then if y equal to A plus bx, then mean deviation of y will be given as modulus of B into mean deviation of x. Okay, so we need to find the mean deviation of y here. So MD of y, MD mean deviation about of y will be equal to sorry, I should not write like this, I should write like this: mean deviation of y about whatever average will be equal to modulus of B, that is 4 by 3 into mean deviation of x, which is given to you as 5.40 into 5.40, and that can be calculated as 4 into 5.40. Let me calculate it as 4 into 5.40 will be equal to 21.6. Okay, so 21.6 divided by 3. 21.6, and then what we need to do is 21.6 divided by 3 will give you 72. So what we have here is 7.2. So 7.2 is the mean deviation about or of the variable y. Okay, that's it for this class. So we have covered all type of problems that can come from mean deviation. Thank you.